Hello student, here is the question that resistance of an ideal voltmeter. So resistance of an ideal voltmeter, what voltmeter does, it just measure the voltage of the, here is the current, okay. So here is the volt circuit and you are connecting a voltage here. So what voltage do? It just measure the potential difference across this resistance. Okay, whatever the current is flowing, okay, whatever the current is flowing in this circuit, potential, this voltmeter is measuring that current. Okay, for this, what is the accurate value of this this potential difference across this? Let's say that's equal to A and B. So VAB should come out to be theoretically that's equal to R, I into R. Okay, but if your there is some resistance of your if there is some resistance of your voltage, in that case what will happen, just see here, this is the resistance, this is the resistance, and voltmeter is also of same resistance, which is this is the voltmeter resistance, and that's also equal to R. So half of the current will pass through half of the current will pass through this and half of the current will pass through this, and the potential difference between A and B will be now VA minus VB, that will be equal to IR by 2. Okay, so it's what should be its value, what should be the potential difference across actually what should be the theoretically potential difference between these 2 points, this should be equal to IR. Okay, but what you are measuring now, if your resistance value is equal to the resistance which is connected in the circuit, okay, so this half of the current is going through this path and half of the current is going through that path. Okay, so here value is coming out to be half that of the real value. If you are taking that this resistance should be, if small, then most of the current will pass through that, and you are measuring the low voltage difference across the V and B. If you are taking the high voltage, okay, if you are taking the high resistance of the voltmeter, so most of the current will pass through that. If you are taking the infinite resistance of the voltmeter, what will happen? Just see here, that's voltmeter resistance is infinite. Okay, so here is the resistance is infinite. So here is the resistance R. Now just what is the current over there? Now in that case current is I flowing through this one. Okay, this is the circuit you have. This is the circuit, and now resistance of that voltage is infinite. So here you have to measure this current, that potential difference that should come out to be I into R. So here, if this is infinite, so you will write that's the current in this branch, that's the I1. So I1 will be equal to that's the resistance. This is 1. So this is the resistance R upon sum of the resistance R plus infinity. You are dividing this current into total current, that's equal to I. How much current is that's equal to 0. That means no current is flowing as such in this branch if this voltage is infinity, this resistance is infinity. You are measuring the, in that case total current will flow through this path. Okay, and potential difference will be equal to I into R, which matches with your theoretical calculation. So for an ideal voltmeter, the resistance should be infinite. So that should be infinity. Okay, so there should be actual value. Theoretical and practical value will matches if it is infinity. Okay, but in generally, okay, it is not infinity, it is having some high values. Okay, so this current is negligible, you can assume, and it gives your approximately closer value to the theoretical value. Okay, so for an ideal voltmeter, that's the ideal condition. Okay, for ideal voltmeter, that resistance should be infinity. Okay, thank you.